everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 16 physics series, where we have completed all the second PU chapters. Now today I will start with chapters of first PU, and today is the first chapter of first PU revision, that is units and measurement. Here this chapter is little bit big in terms of content, but only one question comes from this chapter, so I will try to complete the chapter in one go. It will be slightly longer video, but it will help you also if you are preparing for any other competitive exam. For example, if you are preparing for JEE or if you are preparing for NEET, then this is a perfect chapter for you, because a lot of conceptual question comes from this chapter. Now for KCET student, only one question comes from this chapter, but this has a lot of coverage, so if you want to answer that question, you have to learn all those things. So I will try to explain as much as possible. Be here with me, and every Sunday we are doing KPL, and for all the class notes, all the latest update, what you have to do, you have to join our WhatsApp group. The link is given in the description, and if you join our WhatsApp group, every Sunday you will get a question paper absolutely free of cost. There is no cost associated with it. Only thing that you have to do, only payment that you have to do, you have to click on this link, join our WhatsApp group, and you are ready, right? You know the drill. Now let's start with today's list of topics. So let us look into the list of contents. First we will discuss units and measurement, then we will discuss international system of units, then we will discuss supplementary and derived units, and then we will discuss significant figures and rules of significant figures, and lastly we will discuss dimensions and dimensions analysis. This is the first chapter of your first PU, so maybe you have forgotten some concepts, so just for a revision, because you have already completed that, I will try to cover the chapter quickly as much as possible. So let's start with units and measurement. So first of all, what is the meaning of measurement? Fundamental process in science to quantify a physical quantity. So for example, if I say I am heavier than you, what is the meaning of that? I am heavier than you, I am taller than you. So these are just comparative terms, but that is not very unique terms, right? So when I say my height is 5 feet 9 inch, then you will know, okay, sir's height is 5 feet 9 inch, my height is 5 feet 8 inch, so sir is 1 inch taller than me. In future, if your height becomes 6 feet, then you will say, okay, my height is 6 feet now, so I am taller than sir, right? So this is just an example. Also, if I say my weight is 70 kg, you say my weight is 50 kg, so sir is 20 kg heavier than me. So these are the things that quantify things. Instead of saying in terms of comparison, if there is a measuring value, if we measure universally, then that is called measurement, right? Now what is the meaning of physical quantity? So physical quantity, we are quantifying physical quantity, right? Now what is the physical quantity? Any quantity that can be measured and described by a number and a unit. So physical quantity is something that you can measure it, right? So for example, you can measure weight, you can measure mass, you can measure height, you can measure any distance between 2 points. These are called physical quantities, okay? But if you say I dreamt yesterday, okay, for some time, but you cannot measure the dream, how much weight of that dream or how much important was that dream, so that you cannot measure, so that is not a physical quantity. So physical quantity is something which you can measure, right? When we are measuring any physical quantity, we are comparing it with a certain basic, arbitrary chosen, internationally accepted reference standard called unit. So what is the meaning of unit? Whenever I say, so for example, I gave you one example, my height is 5 feet 9 inch. Okay, 5 feet 9 inch, what is the meaning of 5 feet? So there is a measuring stick available somewhere in the world. They said, okay, this distance is say 1 feet. So that if you are 5 times that distance, then you will be 5 feet. So that distance measuring scale is there somewhere. Okay, so that is internationally accepted. Even though it is not international unit standard, you will see what is international unit standard, but feet is also accepted, internationally accepted height, internationally accepted length of unit of length, right? So something which is, and it was came to us just like that. Okay, we by referencing, by practicing, we decided, okay, this much is 1 centimeter, this much is 10 centimeter, this much is 1 feet. So everything was arbitrary. Okay, there is no proper reason why we chose this is to be 1 kilogram or this is to be 1 feet. Okay, there is no such reason, and that's why it is called arbitrarily chosen. Okay, the result of measurement of a physical quantity is expressed by a number accompanied by a unit. As I said, if I write just like this, if I write say 2, what is the meaning of that? It is just a number. In mathematics, it's just a number, right? A real number. But if I add this, then what is this? Now this will be a unit. It is a mass, right? This is a mass. Now what is this? Same number can be represented using for different quantities. This is mass, this is distance, right? Or if I say 2 hours, that means it is a time. So same quantity can represent, same value can represent different terms. So that's why unit is very, very important. What is the unit of that quantity? So that's why whenever you are writing some exam in physics, it is said that you have to write the unit. So unit, that's why unit is very, very important, and this is the number and this is the unit. Now let's move on to international system of unit. Système International de Units. Okay, Système International de Units. This is the full name. Okay, or SI, that what we say. Okay, SI system was developed in 1971. It is very recently. You can see this is almost 50 years back, not very old. For international usage in scientific, technical and commercial work. Standardized units adapted internationally for consistency. So for example, there was a time when British people, they used to use a lot of foots, pound, etc. right? Whereas Americans and Indian people, they used to use kilograms. Okay, they used to use centimeter, meters, etc. So different parts of the world are were using different values of units. So there was a lot of discrepancies. Okay, so to remove that discrepancy, what happened is that they assume that, okay, this is the discrepancy, we have to remove this discrepancy. So whenever we are dealing internationally, okay, we have to adopt certain fixed standard. Okay, that standard later converted into system or international day units. There was a convention, okay, and then they added, okay, these are the international units all over the world. Wherever you go, these units will be always accepted, right? Now let's see the list of the terms. So there are few terms which are considered to be unique, okay, or primary units. Okay, so these are the primary units: length, time, mass, electric current, thermodynamic temperature, okay, luminous intensity, amount of substance. These are the primary units, and all other units are considered to be derived units. Okay, and what are all the unit for that? For length, international unit is meter. Okay, for time, international unit is second. For mass, kilogram. For electric current, ampere, and for thermodynamic temperature, Kelvin. Very important. Sometimes we casually say temperature, but thermodynamic temperature means temperature of the object. Okay, so that is what we are talking about. Luminous intensity, that is candela, and amount of substance is represented by mole. Okay, and their symbols are as given as this. So I hope you are already familiar with the units, primary units, and their symbols. Okay, now there are two supplementary units, okay, which is angles. There are two angles. One is plane angle, another one is solid angle. Plane angle is measured using, so this is a arc, okay. So arc length is suppose ds, and distance from where you are measuring the angle, so the distance is r, then this angle d theta can be measured using this formula ds by r, and the unit of angle is radians, rad. Okay, radians is the unit of angle, but later on you will see this has no dimension. Okay, this is one of the dimensionless quantities. Anyway, let's move on to the solid angle. Solid angle is basically when you are measuring angle of an area. Okay, so there is an area and you are saying what is the solid angle. Solid angle, obviously to measure an angle, what you need, for example, for plane angle, what you needed? For plane angle you needed a curve and a point. Okay, so there was a curve, and depending upon the point where you are measuring this, the angle value will change, right? If you measure here, the angle value will be less. If you measure here, angle value will be more, right? So distance is important. What distance is from the point where you are measuring the angle. Similarly, for solid angle as well, from where you are measuring, suppose that distance is r, okay, and the area of the solid surface is, say, dA. Okay, then the solid angle is denoted by the symbol omega, d omega. For example, theta is for normal angle, okay, and omega is for solid angle. Okay, the symbol is d omega equals to dA by r square. So normally for plane angle it was ds by r. For angle it is dA by r square, and its unit is radians. Okay, now let's move on. There are few common derived units: velocity, acceleration, force, work, power. Okay, power is work per time, so this is common unit is watt. Okay, so these are just common units you should be familiar with. Now let's move on. Find the value of sine 1 degree without a calculator. Obviously without a calculator. Now this is an interesting question. How can you answer this question? Now to answer this question, we need to know one thing, that sine theta nearly equals to theta for small value of theta and when theta is expressed in radians. Very important. Okay, so if you think, okay, sine 1 degree is equal to 1, obviously not. Sine 1 degree is not 1. Sine 0 is 0. Sine 90 is 1. So sine 1 degree cannot be 1, right? So how can we solve this? 1 degree. If you remember, how can you convert degree to radian? Angle multiplied by pi divided by 180. Okay, here pi is 3.14. So this is the radian. This is you have converted 1 degree to radian, which is nothing but pi by 180. Now if you see, this is very small value. Pi is 3.14 and you are dividing it by 180. So almost 200. That will be 0.00125, whatever value it will be. So it is a small value, right? 1 itself is not small, but this is a small value. So we can say that sine pi by 180, which is a small value, itself nearly equals to pi by 180, right? So this is the value of sine 1 degree. So you can say, okay, sine 1 degree is pi by 180. Simple question. I hope you enjoyed this problem. Now let's move on. Next is significant figures. Another important part. Okay, now whenever I say there is a number, not all numbers are significant. There are few things which are significant. There are some things which are not significant. For example, if you are preparing for KCET exam, you know that part of your PU score is getting added to your KCET exam. For example, if you are opting for engineering courses, then your physics, chemistry and maths marks are very important, because that marks not only is getting added to your PU board, they are also getting added to your KCET exam. So with respect to KCET exam, they are significant. Whereas your English, Kannada and Bio, whatever subject you are appearing for, English, Kannada, Bio or computer science, those subjects are not significant because they are not getting added to your KCET exam. Only in terms of KCET exam. For PU board exam, PU board score, they are all significant. But for KCET exam, only physics, chemistry, bio marks are important. Right? Now let's move on. significant figures are the digit in a measurement that are reliable plus the first uncertain digit. Now what is the meaning of that? Suppose you are measuring a distance between 2 points. Okay, so measuring a distance between 2 points, you saw that scale, in your scale you have, suppose it starts from 0, it next is 1, 2, 3, like that. Okay, 3, okay, 4, like that, and in between you have some digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you have these values. Okay, now if I give you this scale, and if I give you, okay, what is the value of this case? Okay, so you will say, okay, this value, this line is, this is 1, this is 2, this is 3, so 3 centimeter wide, this line is 3 centimeter wide. Okay, but it is not exactly 3.1, it is less than 3.1. so how can I say which one is okay? So to do that, what we will say, okay, I can say the value is 3.05. It is between 3.1 and 3.0, right? So that's how we write. Right now, how many significant digits are in there? Significant digits will be 3.0. So 3.0, the actual correct reliable digit is 3 and first uncertain digit is 0. So this is what we say. So in some cases that might be a actual value, in some cases it will be point only. So this is the significant digit. Now similarly, if this arrow line, instead of here, if it appears here, what will happen? What will happen now? Now what will happen is, the significant digit is, if you will see, okay, now the number is 3.1. 3.1 is the actual value. Okay, minimum this is correct, and it is between 0.1 and 0.2. So we will say 3.15. So now this is our significant digit. You cannot say 3.152, 3.156, whatever you might say, but actually 3.1 is correct value and 0.5 is our first uncertain digit, because you will not say with certainty it is exactly 3.15 or exactly 3.14. You will not be able to say that because you don't have the scale accurately to measure this length, right? So this is the significant digit. Okay, sometimes we can measure exact value, sometimes we are not able to measure exact value. If we are not able to measure exact value, then this is called, this is how we determine the significant digits. Okay, significant digits are those obtained by a measurement and not by calculation. So remember that significant digits only occur when we are doing the measurement. Okay, it is not from the calculation. Very important. Now, few common rules of significant digits. All non-zero digits 1 to 9 are always significant. Any digits whenever you are measuring, okay, if the digits are non-zero, then they are always significant. For example, 123.45 has 5 significant figures. Okay, 1, 2, 3, 4, 5, 6. Even if there is a decimal, we do not count decimal as long as all the digits are non-zero. If all the digits are non-zero, everything is significant. Okay, now leading zeros. Now if you are writing a decimal number, okay, less than 1, okay, then all the zeros which are before the number, actual first non-zero number, they are not significant. Okay, this 0 is never significant, this 0 is never significant, and because these two zeros appear before coming to this number, first number is, if you see, first digit, actual digit, non-zero digit is 2. So we will not consider these two numbers, these two zeros as significant. Okay, here only 2 and 5 are significant. So significant figure in this case is 2. Very, very important. Okay, now now sandwiched zeros. Now what will happen if the zeros are sandwiched? So in this case, these two zeros are significant. So for example, if I say 3.002, so how many significant digits are here? 1, 2, 3, 4. So in this case, if first number is not 0, okay, and then there are some zeros in between, in that case those zeros are significant. Zeros between non-zero digits are always significant. Very important. Okay, next is tailing zeros, okay, in a decimal number. Tailing zeros in a number with a decimal point are significant. For example, 50.00 has 4 significant figures. This is interesting, this is important, okay. So this is exactly in contrast with the number that we have learned in the second point, okay. So in second point we learned that if it is like this, then only this is significant. But now we are saying if this is like 50.00, all the zeros are significant. All the zeros, including non-zero numbers, are always significant, right? But if we are writing like this, then all the zeros are significant. Tailing zeros in a whole number, okay? Tailing zeros in a whole number with a decimal point. Tailing zeros in a whole number with a decimal point are significant. So a whole number is 100. 100.0 has 4 significant digits. So in this case, all the zeros, if there is a decimal point, then they are significant. Tailing zeros in a whole number without a decimal point, okay, if I say the number is 1500, then only 15 is significant. Last 2 zeros are not significant, okay. It is very important. As soon as if you add a decimal here, then these 3 zeros also become significant. That is the beauty, okay. So basically what it means that the measuring device which you are using to measure the distance, okay, it can measure up to 0.1, okay. That's why it is not able to measure 0.1, it is less than that 0, so that's why that 0 is significant, and that's why all the zeros in between are getting significant. But if I say 1500, then you are saying that it cannot measure a value beyond 1500, it cannot measure value in between 2 numbers. That's why these 2 zeros are not significant, okay. These 2 zeros are not significant, only 2 significant figure in this case. Exact numbers, okay, exact numbers are infinite significant figures, okay. Why infinite? Suppose I say exact number 1 dozen. 1 dozen equals to 12. So 12 can be written as 12.00000. It is an exact number, so you can write up to infinity because it will always give you 12 only. It will not have any discrepancy in between the number. Exact numbers are infinite significance, okay, because as I said, after decimal all the zeros are significant. So if it is an exact number, 12 for example, normally 12 is not exact number, but 1 dozen is an exact number, okay. 1 dozen or if I say 1 ton, that is an exact number, right? They represent exact value. Now scientific notation, all digits in the coefficient number written as the scientific digits are significant. So for example, if I write some number, suppose x times 10 to the power of y, every number in x are significant. This 10 to the power y is not significant. You have to remember that, okay. So if I say 25.56 times 10 to the power of 223, so only these digits are significant, these digits are not significant. You have to remember that all the digits if you write in terms of scientific notation, this is scientific notation, all the digits written in scientific notation are significant, okay, and the 10 to the power numbers are not significant. They are not significant. You have to remember that when you are coming to the significant digit part. Choice of unit, a choice of unit or changing the unit does not change the number of significant figures. For example, if I say 1 meter, how many significant figures? 1. Now if I convert it into centimeter, 1 centimeter, 100 centimeter, how many significant figures? Still 1, okay. Even if you change a number to different units, the significant figures will not change. So they have given you one example. 2.308 centimeter has 4 significant figures. It won't change if we switch it to the 0.02308 meters, okay. Even if you convert it to any other unit into meter or into millimeter, the significant figures will not change, okay. You have to remember that. Now rules for calculation. This is for this is normally when the values are given. Now when you are adding, subtracting or dividing, then when how many significant figures the result will have, that is very important as well. So addition and subtraction, when you are doing addition or subtraction, the result should have the same number of decimal places as the number with the least number of decimal places. Very important. So for example, if I add x y point z a plus say p comma q, suppose I add these two numbers. Now how many decimal places here? 2 decimal places here. How many decimal places here? 1 decimal places here. So my result, suppose my result is e decimal f. So in that case my answer will have only one decimal, number after decimal. Very important. Okay, when you are adding numbers with decimal or subtracting number with decimals, the final answer should contain the minimum number of decimal point. It is not significant figures, it is about decimal point. Okay, you have to be careful. Okay, so for example 12.11 plus 0.2. Okay, 11 point, it has 2 decimal points, it has only 1 decimal point, right? So my answer will have 12.3 rounded off to the decimal place. First you have to do the addition, first you have to do the normal addition. So 12.11 plus 0.2. Okay, 12.11 plus 1.2, so you get 12.31. Now how you have to round it off? Why you have to round it off? Because this has only one number after decimal, so your answer should also contain one number after decimal. So this is the answer. If the number is rounding off, I will teach you the round off rules as well, so that you have to round off according to the given value, calculated value. Multiplication and division, the result should have the same number of significant figures as the number with the less number of significant figures. So when you are doing multiplication or division, in that case your answer, now significant figures is important, not the decimal number. Okay, so for example 4.56 has 3 significant figures and 1.4 has 2 significant figures. So your final answer will have only 2 significant figures. In this case significant figure is important, whereas in case of addition and subtraction, decimal points after decimal, how many digits are there, that was important. But in case of division and subtraction, significant figures is important. So you have to be careful what process you are following. Now next is rounding off. So there are 2 ways to round off. First of all, if the number you are rounding off is less than 5, okay, the number after precede the now digit that to be dropped, that number you are dropping, the first digit you are dropping, if that is less than 5, you can simply drop it. For example, you are rounding off this number to say 3 significant figures, okay, or one number after decimal. Okay, so in that case, which number you are dropping? You are dropping 3, right? So if is this number less than 5, yes, then you don't need to bother about it, you can simply drop it. Okay, dropping means removing it. Okay, if the digit to be dropped is greater than 5, the preceding digit is increased by 1. Okay, so if the number you are dropping is greater than 1, greater than 5, okay, so less than 5, greater than 5. Okay, greater than 5 is 6. So you want to drop this 6. You want to round off this number to 3 significant digit again. And what you have to do in this case, because this number is greater than 5, you have to add 1 to the previous number. Okay, so you need to add 1 to the previous number and it will become 12.5. Okay, clear? Now if the number to be dropped is equals to 5, exactly equals to 5, then the problem starts, because most students don't follow this rule. Okay, exactly what they will do, they will simply add one number and they will think, okay, I am correct. But in case of exact round off, this is not correct. If the previous number, okay, if the previous number is odd number, if so you understood the point, right? This number we are trying to drop, and this number is 5. Okay, so what will happen? Will we increase the number, or we will decrease the number? We will leave it same. So that depends on the previous number. In this case, if this number is less than 5, simply drop it. If this number is more than 5, we have to add 1 to the previous number. But if this number is exactly 5, then this is rounding off also depends on the previous number. Okay, if this number is an odd number, then you have to add 1. Okay, so if the preceding digit is odd, then you have to increase it by 1. So for example, 12.35 now become 12.4. Okay, if the preceding digit is even, okay, then it remains same. So for example, 12.45, you want to drop this 5 and the preceding digit, the digit before that number is even, then you don't need to do anything. You have to leave it as it is. Okay, so because 4 is even, you can write this as 12.4 again. So basically 12.35 is 12.4, 12.45 is also 12.4. So be careful of such trick questions, because there might be some trick questions coming in your KCET exam. This is a simple chapter, so maybe they will ask you some trick questions. So be prepared for that. Now let's look into one example of uncertainty. Okay, uncertainty question came only once in previous year, but I will just show one example how you can do it, and the rule for that: uncertainty should be converted into percentage first. Okay, so, and then you can add them. So what is the meaning of uncertainty? Suppose I say I measured one value A, and I'm not sure, but it may be plus minus B. It is actually either plus minus either plus B or minus B. Okay, based on the device that you are measuring, that device depending upon the accuracy of that device. Okay, there is something called uncertainty. Okay, because your device is not 100% accurate. Okay, whenever you are measuring a value, okay, your device will always add some error because of the device. This is called uncertainty error. Okay, so uncertainty is basically represented like this. Okay, either it will be plus some value or it will be minus some value. Okay, now when you are calculating the uncertainty, okay, suppose now I say, okay, now I have another digit x plus minus y. Now what will happen? Suppose this digit is A, this is a quantity B. What will happen? What is the error in AB? What is the uncertainty in AB? So in that case, many people, what they do, they just simply do this: A plus X plus minus B plus Y. Okay, this is not correct. This is not correct way to solve it. Okay, this is not correct. So how can you solve this? So first of all, what you have to do, you have to convert each of the error into percentage. For example, I have measured the length of a rectangle and I found that the length is 16.2. Okay, and the uncertainty is 0.1 centimeter. Okay, I measured the breadth. I got the breadth as 10.1 centimeter and the uncertainty again is 0.1 centimeter. Now, when I want to calculate the uncertainty, I have to first convert these errors into percentage. How can we convert the percentage? So, what is the uncertainty? 0.1. What was the measured value? Measured value is 16.2. So, you have to divide it. Okay, and you will get a value. So here in this case it will be 0.006. You have to multiply with 100 to get it into percentage. So you will get 0.6%. Okay, so you will get that value as 0.6%. Similarly, for breadth it will be 0.1 divided by 10.1, almost 10. So then you have to multiply with 100 to get the percentage, which is equals to 1%. Okay, so we will get the percentage. So for, even though they both have equal amount of uncertainty in terms of values, when you convert them into percentage, one has less percentage, one has more percentage. Okay, that is why it is important. Now when you multiply them to find the area, now you can add these two percentages. If they are given, if the uncertainty is given in terms of percentage, then you can directly add them. If they are given in terms of values, first step you have to convert them into percentages first. Once they are converted into percentages, then you can add them. Okay, even though there is a plus and minus, uncertainties always gets added when they are in percentage form. Okay, now what you have to do, you have to convert this percentage back to the value. How can we do that? 1.6%. What is the value? This is the value. So 163.62. Now since this is a percentage, so you have to divide it by 100. Whatever value you will get, 0.3. Okay, in your exam, if this question comes, they will give you good values so that you don't need to worry too much about using a calculator. Okay, so this is one example. Now, number of significant figures in this. Now let us answer this question. What is the number of significant figures in this? So what we are doing? We are dividing. So when we are dividing, how can we calculate the significant figures? Significant figures in division is the least number of significant figure in any one of them. So how many significant figures here? 1, 2, 3, 4. So significant figures is here 4. How many significant figures here? 1, 2, 3. So which one is the least? Least is 3. So our answer should contain only 3 significant figures. Okay, you don't need to calculate this value. You just need to count the number. Okay, how many significant figures there in the numerator, how many significant figure in there in the denominator, which one is the least, that should be our answer. Okay, simple question. Now we are talking about dimensions. What is the dimension? Dimension of physical quantities refer to the nature of the quantity in terms of the fundamental physical dimension. So we said there are 7 fundamental quantities, 7 primary quantities. So whenever I say any other quantity, name of any other quantity, how they are related to fundamental or primary quantities, that is our concern. Also, this removes the different values of units. For example, length is measured in foot if you go to England. Length is measured in meter if you go to America. So if you visiting different countries, you have to use different tapes or different values, right? But if I say a dimension of this distance is L, it is valid wherever you are in the world. So dimensional formulas are more correct than units, because units can change from place to place, but dimension values will not change. Only thing, if you know the conversion, you can directly add the conversion to get the values directly, right? Now there are 7 fundamental quantities. What is the dimension of these 7 fundamental quantities? Length is represented using this third bracket L. So whenever we are writing a dimensional formula, it is always represented using this third bracket, which is very important. Okay, so A, B, C, D, L, M, T, whatever you are writing, okay, there will be some powers X, Y, Z. You will always write in terms of third bracket. Third bracket represents the dimensional formula. Okay, so length dimensional formula is L, time is T, mass is M. Okay, electric current can be represented using A or I. Okay, but most commonly in all the books they use capital A only. Okay, thermodynamic temperature K or capital theta, but most books use capital K only. Luminous intensity is represented by CD and amount of substance is represented by MOL. Okay, we drop the E, we just simply use MOL. Okay, now dimensional analysis. Dimensional analysis is a technique to check the consistency of equations and to derive relations among physical quantities using the dimensions. I hope you have used the dimensional analysis in your first PU to solve some problems, right? Now, dimension formula. What is the meaning of dimensional formula? Expressions showing how and which of the fundamental quantities are involved in a physical quantity. And dimensional equation, dimensional analysis is often used to check the consistency of equation in physical and engineering for equations to be dimensionally consistent. So if I say x equals to y, that means whatever the dimension of the left hand side, the same dimension has to be on the right hand side. Okay, so this is very, very important. Also, if I say x plus y, this is possible only when x and y are of same dimension. Okay, so whenever you are adding two quantities, they should have same dimension. Okay, this is not applicable for the multiplication and division. It is only applicable for addition and subtraction. So for example, you subtract 2 kilogram mass from 2 meter road? Not possible. You cannot subtract meter and weight, right? Meter and mass. Meter is a different quantity, mass is a different quantity, right? So if I say you have 2 meter long tape, you give me 1 meter out of that. Yes, this is possible. You can cut it and you can give it. So basically when I say 2 meter length, you can subtract 2 meter length from it, or if you can add meter into it. So when you are adding or subtracting, the quantities must have the same dimension. That is what is dimensional equation. So whenever I say an equation, I write that equation should have, both sides should have same dimension. Now let's look into one example. So I have given you one example, one equation, S equals to ut plus half at square. We all know this equation, but have we ever thought if it is dimensionally correct or not? Let's see. What is the dimension of S? S means distance traveled, right? So distance traveled means the dimension should be that of the length. So dimension of distance traveled is L. Now what is the dimension of ut? U is velocity, right? U is velocity, initial velocity. So its dimension is length, meter per second. Always remember units, SI units. Okay, if you remember SI units, it helps you to remember the dimension. That is one way to remember the dimension. So length is meter, meter means length, S means time, but it is in division. So L to the power minus 1 is the dimension of U. This is the dimension of U. And T means time. Times dimension is time. So this T to the power minus 1 and this T cancels. So we get the dimension as L. Now what is the dimension of AT square? What is A? A is acceleration. Its unit is meter per second square. So its dimension will be, M is meter, that is L. A square is in division. So T to the power minus 2. Right? So L T to the power minus 2 is the dimension of A, and times T to the power 2, because time square is there. So its dimension is also L. So whenever I say it is dimensionally valid, that means this equation should have the same dimension on left hand side and same dimension on right hand side. So thus L is equal to L plus L. Okay. Only quantities with same dimensions can be added or subtracted. Very important. So if you see on our right hand side, what is the dimension of this is L. What is the dimension of this? This is also L. So they can be added. Okay, if they don't have the same dimension, you cannot add them. Now let's solve one question. If P, Q, this is from your KCET exam. If P, Q and R are physical quantities having different dimensions, which of the following can never be a meaningful quantity? Very, very important thing. So first of all, P, Q, R are physical quantities having completely different dimensions. Different dimension means what? You cannot add any two of them directly. You cannot subtract any two of them directly, right? So basically you cannot do that. They are directly being subtracted. Okay, so and they have said that which one does not make any sense. Okay, so only one option is correct. So this one does not make any sense. So this is the correct answer. Okay, these all are possible. Why these all are possible? Let me give you one example. So here P, Q by R. P, Q, R, all of them are different dimensions, but when you multiply P and Q, they can have the same dimension as R. Right? So for example, suppose P is mass, dimension of mass. Okay, Q is acceleration, dimension of acceleration. Okay, so what is PQ then? PQ will be mass into acceleration. What is the dimension? Now R is another quantity. It is represented by force. Okay, so force means it will also have the same dimension as MA. So PQ by R, even though the dimension of P, Q and R are different, but if you say PQ by R, you can say okay, MA by F. So they have same dimension. So this division is possible. Okay, so for division they may have the same dimension. Also for division, not necessarily they should have the same dimension. Okay, it is not necessary for division or multiplication that they should have same dimension. But if you are subtracting or adding, they must have the same dimension. Okay, this is valid. Okay, this is valid. This one is also valid. As I said, P into R can have the same dimension as Q square because it is not mentioned. As long as they are getting multiplied, multiplication means a new dimension comes. Whenever two quantities are multiplied, a new dimension comes that can have same dimension as other quantity. Right? Here also P times Q can have same dimension as R. So I gave you the example. So P is M, Q is A, R is F, then MA minus F is quite possible, even though they have say different dimensions. When you multiply both two quantities, they could have the same dimension. So these three all are possible. Okay, which will never be a possibility is this, because you cannot subtract two differently dimension quantities. Okay, this division is okay. This division is okay. Division you can do, but this step P minus Q is not possible. P minus Q is not possible because P and Q are of different dimensions. Now let's look into one more question. The SI unit of energy is joule equals to kg meter square per second square. That of the speed v is meter per second, and that of the acceleration a is meter per second square. Which of the following relation for the kinetic energy can you rule out based on the dimensional consistency? Okay, so kinetic energy's unit is kg meter per second square. Okay, and v is meter per second, and that of acceleration is meter per second. Okay, so now you have to find the dimension of these quantities, and you can ignore which one will have a different dimension. Okay, now we know that this is equals to half mv square. Right, kinetic energy is half mv square. Which one is incorrect? So which one you can rule out? Rule out means which one is incorrect. So definitely this is correct. Okay, now is this correct? This will definitely may not be correct. This question should have options like A, B, C, D. Okay, only A. Okay, A and B, A and B and C, A and C and D. Okay, these should be the options. Okay, this question is not 100% correct because as you can see, this answer is correct. Okay, this is correct answer. If you multiply m is kg, okay, v square is v square means meter square, second to the power minus 2. So this is correct. This has the same dimension. Will it have the same dimension? If you do the meter square means mass square means kg to the power of 2, kg square, here we have only kg, so this is not possible. Similarly, if you say this is kg meter per second to the power minus 2, this has one less meter square, so this is also not possible. Similarly, this is also not possible, even though this is correct, this is not correct, so this is not possible. So any one A, C and D are not possible, so correct answer should be option D. So this is a common question. Now we have reached at the end of this lecture. If you liked this lecture, don't forget to follow our channel, subscribe to our channel and share it to your friends. I'll be back with some PYQs of this chapter as well as some additional questions from this chapter, as there are not many questions from this chapter, only 10 questions from your previous 10 years question paper. Each year only one question is coming, so I will add a few more. I will make it 20 questions and I'll be back with 20 question answer tomorrow. Till then, bye.